Hello guys, welcome back. I'm a bit disorganized today. You can see I have not put the green screen up yet, but I'll do that in a minute. Um, Hope you're all fit and well and healthy. I'll quickly do a register now and then we'll start properly. So, if I can remember how to do this, it's been 2 whole weeks. Is everything working? Can you hear me? Can you see me? This is my first stream of the week. Why isn't Jan on the intro? Maybe I'll try and get her on the intro in future episodes. Get some guest stars. All right, attendance. Let's sort this out. Online registers. There we are. Okay, let's have a quick look on the other console. See who we've got. Yeah, she'd put me to shame, to be honest, Jolly. So it's a pride thing. What have we got streaming today? Did everyone have a good Easter? Oh my God, Easter holidays. Everyone have a nice time? All right, so we've got Charlie. Charlie, you're present. We've got Alex. We've got George. We've got Becca. It's really good this is not in alphabetical order. Nice confusing. Got Becca, got Sophie, got Fifi, Roddy, Callum. That who else we got? Joe and Caleb, Leo. Who's out? Who else is there? I can't remember what your tags are. So if you guys are here, please, Leo, Joan, and Caleb. Oh, Joan is here. Cool. Right. So just missing two of you. That's not too bad. If you two watch it at some point, let me know, and I'll tick you off the list as well. Cool. All right. So plans and stuff. So need to explain what's going on for the next few weeks for you guys. So you will all be having your year one exam or test during the week, the 27th of April. Leo's here, good. And the exam will be up on Moodle. So, yeah, you can do it, I think, anytime between the 27th, 28th, and 29th, but it needs to be handed in by the end of the 29th. And then we mark it on Thursday, the 30th, and Friday, the 31st. So, yeah, that's when your exam is going to be. We expect it done in exam conditions, but obviously there's an element of trust in that. So yeah, please make sure you get those done and handed in on that date. So you've got till then to revise, which is 2 weeks away. You've got a bit of time to do some revision. We're going to be revising with you till then. Today the plan is, or today and Thursday, the plan is to get through a past paper with you guys. So we'll be doing that in a minute. We're going to do an applied paper this week. I think Helen's doing a pure paper. Then next week we're going to swap. You're going to have to scan or photograph and email it. And if that's an issue, you're going to have to post it to college, and there might be a bit more of a delay on it. But ideally, you'll be able to photograph or scan every page and email it to myself or Helen. I'm not sure who's going to be doing what, but yeah. Cool. So this week we're going to be looking at applied paper G, and next week we're going to do pure paper A. But you guys should still be revising in your own time as well. All the past papers are up on the Further Maths Moodle website. So you should aiming to do, I think, 2 a week really, to make sure you guys get the grades that you deserve and the grades that you want to progress into next year. Cool. Everyone okay with that? We're gonna get started on this paper if everybody's right, and I'll set the green screen up. You can see the mic stands behind me where it hangs. So yeah, anyone got any questions? Are we all good? I guess we're all good then. Cool. All right, let's see if this works. Google Drive. No, that has not worked. Cool. All right, I was worried this might happen. It's taking ages to sync. Why are you taking so long to sync? Sorry, guys. Let's see what's wrong with this Google Drive. What's it trying to do? It's trying to sync. Who knows? Pings and stuff. Let's just delete it. Come on, machine. Sync me to Google files. Is it gonna do it? Okay, let's download them on the iPad. I think we can do that. Give me 2 seconds, guys. I will be right back with you. Cool. Right. So you'll see the intro again. You have to wait till Thursday, I'm afraid. If you guys want to log in as well, you can download the paper. Oh, better hide my password. Almost. Cool. Courses for the Maths 2020. We're looking at applied paper G today. Cool. How we're going to do this then is I'm going to set you guys a question and a tight time scale, and then we're going to go through it a few minutes afterwards. So this is going to be a mix of mechanics and statistics. We're looking at G, which is down here. So this is where you find all the past papers for your own general revision anyway. If this will load, there we go. Stats mechanics, paper G. And hopefully Google will sync the files I'm trying to use by the time we need to start going through these. Yeah, weird. I'll try Dropbox as well. So we're going to start off with this one. So if you guys could open this up on your computers as well, just so you've got. I can't fit the whole. I can't fit the whole question. So got an engineer believing there is a relationship between CO2 emissions and fuel consumption for cars. A random sample of 40 different car models is taken. Don't know where this is. I just showed you. Go on to Moodle, go on to Further Maths 2020, go to Applied, Past Papers, and then Past Paper G in the Additional Papers folder. If I go back. Moodle, Further Maths 2020, Applied, which is right at the bottom there. go on to practice papers, additional question papers at the bottom, and then paper G is the one we're doing today. Cool. Anyway, so first one is only 7 marks. So I'm going to give you guys, I think, 5 minutes to give this a go. If you can bring it up on your computers, and we'll start having a look at this. I'll try and port it over into the other software. So if I leave you guys on this screen here, there's your graph. You can bring that up yourself though, and it's 40 different car models. And they found that the PMCC is minus 0.803 because someone passed pencil. Who is that? No idea. Yeah, I'll pass this on to you guys, and yeah. So if you give this a go, and 5 minutes time, we'll start going through it. So I'm gonna disappear off the screen for now. Yes. Good, Jen. Good to see you're keeping up with things. Right, I'm gonna try and bring this up via Dropbox in a second. That's why all this stuff's moving. Because Google has let me down. There you go. So if you guys have a look at that, I'm gonna try and get this working on Dropbox. Which might not even be on this iPad. Stern, Further Maths 2020, one more time, Further Maths 2020. Then go to Applied, and then to Additional Papers, and then it's Paper G. Cool, last couple minutes, guys. Yeah, we're going to go through this one right in a minute, Fifi. We're going to do it like question by question. Don't worry about that. Cool. All right, let's just start going through these then. So if I bring back the iPad, whiteboard of me. Cool, there we go. All right, so hopefully this will now work. Dropbox, Dropbox. Allow. Okie dokie. So first question. Look at that, lovely. Technology is working once again. Okay, so we've got our sample here. I'll do the green screen in a minute. I haven't forgotten. Okay. So key things from this is the R value is minus 0.803. I'll move everything up. No, I don't think we need anything else from there. So first thing it's saying is what is measured by the product moment correlation coefficient. So if you guys comment your answers, what do you think is measured by the PMCC? Any ideas? Correlation between two? Yes, I suppose. The problem is if your answer is you've used the word correlation, and the word correlation is actually already kind of mentioned, so we can't really say that. Strength of linear correlation, correlation between two variables. Yeah, we can say it's the linear association. So let's write this down word for word. Linear association. And we ought to say which variables it's between. So this one will be the linear association between C and F, or between carbon dioxide emissions and fuel consumption. Between carbon dioxide emissions and fuel consumption. Cool. All right, part B. State of a reason whether a linear regression model based on this data is reliable or not for a car when the fuel consumption is 60 miles per gallon. What do you reckon? Is 60 allowable? Is a linear regression model based on the data reliable or not when our fuel consumption is 60? So another, I don't know, 30 seconds. See if you guys can come up with an answer for that one. No, Wi-Fi feed. No on its own wouldn't get you the answer because it does say state with a reason. Requires extrapolation. Yeah, what is that though? We ought to really kind of state what they're trying to get at here. What is actually? Yeah, I feel like you might be just reading the mark scheme there, Joan, because that is kind of what it says in the mark scheme. What is extrapolation? I feel we ought to say what what extrapolation actually is if we're going to use it. It's off the graph. Yeah, we can probably improve that answer as well. Outside the data, yeah. Okay. So 60 is the estimation would be an extrapolation. So therefore extrapolation valid answer for that one. Cool. Okay, part C. Write down the explanatory variable. So for the regression model, E equals 1.98 minus 1.7 times F. What is the explanatory variable? So I think they're using E for emissions and F for fuel consumption. Which one is explanatory though? Oh, Caleb, you're here now. I'll sign you in because you missed the beginning, I think. So we have a full house. That's good. What is an explanatory variable? That's exactly what the question is asking. Do you guys remember? It goes by another name sometimes, but in this case they've called it the explanatory variable. Okay, why, Roddy? What does it mean? Yeah, so it's the variable that explains the other one. It's the variable that causes the other one to change. So yeah, we can say the explanatory variable is the independent, which in this case is F. Squiggly F again, it's just a letter for one of the variables. So I think they're using fuel as the squiggly F. Okay, next bit. Was it say state the definition of a hypothesis test? This is slightly harder. So what do you guys know for? Yeah, same as independent. What do you guys know for the meaning of the what is a hypothesis test? Because you should have looked at all three now. You should be able to say what they are. Any ideas? Testing for a change is something that's probably too vague to get Any marks there? Yeah, I like that, Joan. That's a decent. That sounds like a Google search there, Charlie. But yeah, you got you got the kind of right idea. So, hypothesis test is you are using a sample, so a small subset of a population, to test whether there's enough evidence in the sample to suggest whether something is true for the whole population. So you're using the sample to test if a parameter of a population is likely true for the whole population based on what you can see in your sample. So we'll say it's a test to see if there is evidence in a sample to infer a parameter or a condition. To infer a condition on a parameter for a population. I've done that a bit big there. So test to see if there's evidence in the sample to infer a condition on a parameter for a population. But you got to use the words population and sample. That's the key bits here. Is you're testing a sample to see if something's true for a population. Cool. The last bit is test at the 1% level whether or not the PMCC is less than 0. So it wants you to do a hypothesis test on the PMCC. So this is probably one of the last bits you did in stats. So let's see what you guys can do. If you need the table, do I have the table anywhere? Perhaps. Maybe in the Google Drive. No, but you guys can do this quickly. If I go back to save that draft. Joan cheated. Oh, really? Forgot how you do it for the PMCC. So you look at the sample size, and then you go to the table, look at the relevant value for the what's it called? The critical value we're looking at. So I'll give you guys the table quickly now. I know it's in this lecture I'm teaching later today. So there's the table. Hopefully you guys can see that on the right here. So if I just take actually let's clean it. If I take a quick screenshot of that, we'll go back to our question. Choose photo. Crop. There you go. Can you guys see that? Is that okay? Hopefully you can. I'll give you coefficient is likely to be less than 0. So it's going to be a one-tail test. There you go. So I'll give you guys a sec to do that. While you do that, I think I'm going to put this green screen up. There we go, much better. Alright, so what have you guys done so far? It does, it looks good, doesn't it? It's quite fun actually seeing it in real time in this floating head. Is the answer yes? I don't know, back it up with some evidence. So our sample size is 40. As you can see in the table, 40 down there. And we're looking at the 1% significance level for a 1% for a one-tailed test. So 1% going to be in here. So what's our critical value? Could you guys find it? And don't forget to state your hypotheses because it wants you to state them clearly. Yep, 0.3665, good. Okay, let's go for it. So if you look in the table, you can see the value there, just about 0.3665. We need to state our hypotheses. So H0 is going to be that and weirdly, we use rho instead of R for these. So for this one, we state rho is 0, and that's always the case when we're testing the PMCC. And very interesting they're doing. And H1 dot dot rho, we're testing to see if it's less than 0. So that's what we want for this one. Okay, so we do our test. Our critical value is 0.336, but because we're looking for a less than and a negative correlation, we're going to use minus 0.33665. This is our crit value. Then we're going to look at our test statistic, which in this case is minus 0.803. So minus 0.803 is much less than minus 0.3665. Therefore, it's in the critical region. So therefore, reject. I can't see this, can you? Therefore, reject H0 and accept H1. And we say there is evidence to suggest that the correlation is less than 0. So reject H0. And then you can say there is evidence to suggest that the PMCC is less than 0. Let's see if I can fit that in here somehow. Evidence to suggest PMCC less than 0. That was hard. Cool. Anyone got any questions about doing that hypothesis test? Because if not, we're going to move on. Okay, question 2. Is this one. Can you guys see this? No. There you go. All right, could you guys try this? So it's 8 marks in total. I will give you 8 minutes, maybe slightly less than that, maybe 6 minutes to do it. There we go. So let's hit the timer up for 7, See how you guys get on. Comment if you need any help, and comment when you found what the answer is meant to be. How do you get the critical value? All the critical value is the value either below or above which you reject the null hypothesis. So every hypothesis test has a critical value. Um, the value we just found when we looked through that table was the PMCC. Sorry, was the critical value for the PMCC. So if the PMCC in our sample is less than that value, it's statistically significant. Does that make sense, Joan? How do you mean? There'd always be tables. For the PMCC hypothesis test, there's always a table. For the normal distribution, you're testing the sample means, so you'd find a critical value for the mean to be less than. Yeah, you calculate that one. And then for the what's the other one? Binomial distribution, again, you'd find a critical value for how many trials would be critical. So yeah, for this one, use a table. For the other two, you generally always have to calculate it. What's tracking? Where does it say that? Tracking is when you line up your car tires. So, um, it's like lining up the tilt. Yeah, and this is probably true. Yeah, when you get new tires, you normally need to get them tracked properly. Because otherwise they're on a weird axis and they wear unevenly. That's my little bit of tire knowledge for you there, Callum. Don't forget to copy your answers in, guys, when you've done it. Yeah, nice guys, decent. Yep, that's part C as well. See if you can get part D done as well in the last only drive first. Funny, relevant and good. Yep, Charlie, that is correct. All right, let's go through this. Ooh. Cool. Yeah, okay, so it's got to start with a Venn diagram, which is annoying to draw, but let's give it a go. So, new tire 0.33. If they need, okay, I'm just gonna draw over the things, and we'll get rid of this in a minute. So, well, maybe I can fit it here. Yeah, let's try fit it. So we got tire, no tire, tracking. Let's use TR, no tracking, tracking, no tracking. And we'll try and fill it in. So you found the probability needing a tire 0.33. So we got 0.67 that we don't need a new tire. And that car needing a new tire has a probability of 0.7 for tracking. So we've got 0.3 there, and 0.04, and 0.96. Which I'm aware you guys can barely see. Let's move it on up. There you go. Okay, so there's my tree diagram. You need to have all those bits in there and labeled. Cool. Okay, find the probability a car has exactly one of the two defects. So we can either have tracking. I know we can't. What we're talking about. I'll do that. We can either have new tire, no tracking, because that's one defect. I suppose it's a defect. And the other one we can have no new tire and tracking. So we need to multiply those two branches and add them both together. So we're going to get 0.33 times 0.3 plus 0.67 times 0.04, which you guys correctly said was 0.1258. And then the second one, find the probability. Okay, the mechanic also finds new brake pads is 0.35, but that's independent to the other ones. So for the other ones, we have 0.35 for brake pads, basically on each branch there. Find the probability the car has at least one of the new defects. Well, it could be that probability we already found, so 0.1258, times, oh, hang on. Are we going to need to redo this bit? At least one of the defects. Yeah. So we're going to need to times each of these bits we just did, if you like, by not needing new brakes. So not needing new brakes is 0.65. And the last one is just needing the new brakes. So that's going to be 0.67 times 0.96 times 0.35. And if you add all those together, you should get the other answer of 0.5819. The other thing you could do for at least one defect is you could do 1 minus no defects, like it says in the mark scheme, which is an easy way of doing it, but it's up to you guys. You can do it that way as well. What advice would you give to motorists? Well, the chance that you've got one thing wrong with your car is more than half. It's 58%, 58.2% that there's something wrong with your car. So advice, get your cars checked regularly, because there's 50% chance they need tires, tracking, or brake pads at any point. All right, next question. Question 3. There we go. All right, I have to shrink this one. Hopefully you guys can see all of that. You should have the paper up anyway, so there we go. All right, so this says, and I'll read it out because I think that's tiny. Who are all these other people? No, it is. Anyway, so summary statistics and histogram. Blah, blah, blah. So basically, we're looking at a large data set, and we've got an output from some software about the large data set. So part A, it's only worth 3 marks. I think not very efficient use of a page for 3 marks. Explain why it's reasonable to model the daily mean pressure using a normal. Should be nice and easy. And then based on the output, the information above, what is the chance of poor or bad weather in Beijing during May to August? So, see if you guys can give this a go. It's not worth many marks. I'll give you 3 minutes on the timer. Maybe adjust this, move it upwards. Maybe I can zoom it more. Yeah, cool. Right, if you guys give that a go, 3 minutes on the timer. Type your answers when you've got them. It'd be less than 1,000. I think, actually. Yeah, less than 1,000. They're including a hurricane is bad weather. So a hurricane counts as bad weather. Yeah. So hurricane would be the extreme example of bad weather. Yeah, Callum Potter is right. 1 minute left, guys. See if you can do part B as well. Is the x greater than thingy? What? Okay, so firstly, just want to try and fix the screen because everything's out of whack. Yeah, I don't know where that is. I think maybe it's too big. Yeah, it's not ideal, but what else? Cool, fine. Okay, so yeah, why is it reasonable to use a normal distribution? Well, it's symmetrical about the mean. It's bell-shaped curve, so either of those things would do. Bell-shaped curve. Cool. Part B, based on the output, was a chance of poor or bad weather. Well, poor or bad weather is basically saying the probability x is less than 1000. And we know x is a normal distribution with a mean of 1006 and a standard deviation of 4.4. So that's all my information. If I bring up the calculator, we can do all this on the class whiz. So if I go to statistics, and then dist, and then norm, and then NCD, lower it's going to be 0, upper it's going to be 1000, sigma 4, and mu 1006. And there you have it, 0.668. Wait, have I typed something in wrong here? I think I might have. Lower upper 1000, mu 1006. Oh, 4.4, wasn't it? There we go, fake Charlie. Yeah, 0.0863. There we go. Cool. Is there a part C? Is that it? I think that might be it. We'll see what's on the next page though. So next page. Yeah, there is a part C. Okay. Right, could you guys have a think about part C and part D? So that's another 5 marks. I'll give you guys 5 more minutes to do those. So there's our timer. 5 minutes starting now. What's that? Is number D, letter D, just writing one, a writing one. Yeah, yeah. It's just a writing one. Sorry, I think I hit the page there. Yeah, we'll go through these in a sec. Cool. Right. Yeah, cool. Try and not just look through the answers, guys. I do feel like some of you might be. Maybe that was an oversight on my behalf to show you, show you where everything was saved. But whatever. All right. Why can we say there's no chance of a hurricane in Beijing? Well, if you look back at our graph here, um, although yeah, there's no data for those with a normal distribution, the tails go off as asymptotes, so it never actually goes to zero. So I would just say something like, yeah, maybe mention asymptotes. So normal tails are asymptotes, therefore probability is never zero. And in the mark scheme, they said something about extreme events as well. Same thing. All right, part D is kind of confusing. So if we go back and copy our distribution over, I can't remember what it was now. 4.4 1006. So x and X was the pressure. Cool. And we know that pressure, if you look at this table here, fair weather is 1013. So the mean is not fair weather. The mean is poor or bad weather. So mean, poor, or bad. And what do we say it was? We said fair weather is 1013. Well, if you add 4.4 onto the mean, you get 1010. So even within even within one standard deviation of the mean, you're still talking bad or poor weather. Okay, so it's likely that in Beijing your weather's going to be poor based on the normal distribution we've been given. Okay, so they say the mean pressure for Jacksonville can also be normally distributed. For Jacksonville, then, if you use y instead, y is normal 1017 and 3.26. So, couple reasons. So, yeah, students suggest you can depend on better weather in Jacksonville. So if we look at this, there's two answers you can go for. Fair starts at 1,000, is it? Oh yeah, sorry, 1,000. All right, ignore what I said before. Fair starts at 1,000. Well, um, if you look at these two, our mean for Jacksonville is better, so it has a better mean. Because the mean's better, you're more likely to get good weather. And also the standard deviation is less, so the spread of the data is less. So not only is the mean better, it's also got less deviation in its weather. So the weather is more often than not better because it's more compact. So there's less chance of the weather changing, and the mean's better. I don't know what meme you guys are talking about. Anyway, so yeah, could say it's better because of the mean, or you could say it's better because of the standard deviation. Actually, it's worth 4 marks. Yeah, you want to compare the means and compare the standard deviations in order to get all those marks. So because of those two regions, you can suggest the weather is more consistent and better in Jacksonville. Therefore, the student is correct. So yeah, if you don't actually state whether the claim is supported, you lose a mark. So be careful with stuff like that. If it says state something, make sure you actually state what it's asking you to state. Okay, next one. So I think we're on question 4 now. Yeah, it'd be nice if we could get through stats today, but we'll see how we do. So question 4. And we got data from Campbell and Hand. So we're now looking at two variables. Wind speed. I've seen Incredibles, just not in a long time. I can't remember. Yeah, so we got wind speed and pressure. And we're plotting them both together. So part A, what is measured by the correlation coefficient? This, I feel like we've already done this earlier on in this paper, so this is not very well made paper, but there we go. So could you guys try those two? I'll literally give you 2 minutes to do that, and then I'll, well actually, let's see if I can fit the rest of this. God, there's a lot of it. See what I can do. Yeah, let's try and do all of it, and we'll go through all of it together. Sweet. Cool. Right, so if you guys could try and do this then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 marks, 10 minutes. Sounds fair to me. So if you guys give this a go, and we'll be back in 10 to resolve it. Again, try and do it without looking at the mark scheme. One part C is missing. There you go. Don't know, should I block them all? I don't know who these people are. I don't mind if they watch, but let's shut them up. That's cool, James, whoever you are. I need the PMCC table. Oh yeah, I should actually have it from that picture I took earlier. Choose photo. Recently added. How many is your sample for this one? Um, how many samples have you? What's your sample size? I can't actually see it here. You sure you need it? Hypothesis test. Oh no, there, yeah. Thanks, Roddy. I've also got a load of memes there, so I might have to delete these before the next lesson. I would need to vet the memes before I share them, sadly. Yeah, I was looking for that as well. Sample size. Um, do we need it? No, okay. Um, wait, maybe we do. Yeah, okay, there's one town which is Herne. Yeah, that's fine, Callan, you can rewind. So yeah, this will be all the days between May to October. I guess. Don't know. I don't know why some of these are different dots. No, because it says they're from Herne 2015. All this is from 1 year. Yeah, it's 150 days. So yeah, the sample level is going to be above 100, and we're looking at a 5% level. Yeah, you don't need the table for this, guys. So I'm gonna delete it. Right, so I think there's some confusion over part D, and I was a bit confused for a while too until I read a bit further. Um, I'll quickly go through part D. I'll give you guys a few more minutes to finish off E, F, and G as well because I think you're all stuck on that bit for ages. Or actually, we've got 10 minutes left. Should we just go through the whole thing? Yeah. Okay, so what is measured by the product moment correlation coefficient? Well, that's going to be the linear association between two variables, as we said right at the beginning of this lecture. So that's the linear association between two variables. Comment on the correlation between these variables. Well, it's negative. And it's kind of weak. You could say weak negative. They've got minus 0.44 there as our value, which you can just about see there. Right, part C, interpretation between the correlation. Wait. Oh, okay. As which one's going down? As wind speed decreases, the daily mean pressure increases, or you could set the other way around. So either way like that. As pressure increases, daily wind speed decreases. So you probably want to say daily mean, but I don't have room. So as daily mean pressure increases, daily mean wind speed decreases. Oh, you can't read that at all, can you? but I've said it and you guys can hear, so that's fine. Okay, so this is where we all got stuck. Test at the 5% significance level. Okay, and the issue was you guys are used to having to find a critical value. Remember, that's one way of doing things. One way is you find critical values and you compare them. The other way is you compare the probability values, otherwise known as the p-values. So we're testing at the 5% level. They've told us the p-value for this data is less than 0.001. So 0.001 is less than 0.05. Therefore, it's critical. Therefore, reject H0. And we can say the correlation. There is evidence to suggest negative correlation. So that makes sense to everybody because I think that's where you got stuck. So we're not actually looking at critical regions. We're looking at p-values, which is the probability points instead. So you can either compare critical regions, which is what we normally do, but you can also compare your probability values instead. And that's what they gave you that. So that's why they didn't give you the number of data points. They gave you the p-value. I'll just fly over there and you can see p-value, which is here. The p-value is less than 0.01. Okay, cool. So it's less than that. And our probability was a 5% significance level. So we are way below our significance level. So because we're below, we're in the critical region. Therefore, we reject H0. Then there's evidence to suggest H1. We have negative correlation. Right, what's next? E. Write down the regression model for daily wind speed versus daily mean pressure. Okay. So we've got this is quite confusing to read from the table. What should we say for each letter then? Does it matter? Let's say W for wind speed equals the y coordinate, so 180 is our intercept, minus 0.1694 times pressure, P. This is basically the line of best fit that describes it. Interpret the gradient. So the gradient was minus 0.1964, which means for every increase of 1 hectopascal, the wind speed drops by 0.1694 kilometers. So every HPA increase in pressure for every wind speed decreases by 1 kilometer. I guess that's per hour. Oh, sorry, that's not kilometers. That's a typo. That's a lie over there. It says at the top it's knots, KN. That's naughty. That should be KN. Wind speeds decreases by 1 knot. Okay, and last bit, regression model was used to predict daily mean wind speed. Comment on the accuracy of this prediction. So, we're predicting the wind speed when our pressure is 995. Okay. 995, if we look on our graph, is here. Now we've got 1, maybe 2 dots there. It's not going to be very accurate. So, yeah, there's not many points there. It's near the bottom, near the end of the data. So we're going to say it's not a very accurate prediction because there isn't much data. Our line is based, if you like, on masses of data on the other hand side. So for lower down in the data set, it's not going to be very accurate. Cool. All right. We've got 5 minutes left. I might just set you guys up with the next one. We're doing. Yeah, if you guys could finish off what we were doing. If you guys could finish off the stats, then on Friday we'll try and get all the way through mechanics. If you guys could finish off these two. Oops. Nah. If you guys could finish off these two, that'd be excellent. So I'm shrink that a little bit. There you go. Anyone got any questions? If not, I will see you on Thursday for some for the mechanics bit of this paper. But I'll leave that with you guys. You got the mark scheme as well. If you got any problems with it, we'll quickly go through it at the beginning of Thursday's lecture. Do you want to email the assignments? Yes, please. Email me the assignments and make sure you're revising because these tests are important. They decide whether you go into next year. So revise test is, as I said, the week beginning the 27th. So you got 2 weeks. What assignment are we on? That's a good question. Oh, here's my mark scheme. Yeah, I don't have it on me. Can you guys just check to see where you were before? And I'll email out what the next one is that's due, but some of them got left at college. So I'll double check and let you guys know. As a pure and a stats mechanics paper. Yes, I think you guys will be having both because you finished everything. I'll double check that with Jan, but you should be revising both anyway, so I imagine so. I'll check that with Helen. I think it is going to be 2 papers. It would make sense because you're teaching 2 classes. It's 100% it's pure. I'll double check if it's stats mechanics as well though. Next one's 25 due Thursday. That does sound about right to me. So yeah, if you could get that one done before Thursday, that would be excellent. Cool. Anything else, guys? No. Right. See you then. Stay indoors, stay healthy and stuff, and speak to you later. Bye. Caleb, get 24 done and 25. But if you have to hand in one late, that's fine.